almost all the web application depends on some sort of database for persisting information. So as you have used the databases like PostgreSQL or MySQL to store the information or to store the user data, so that your information will be stored permanently, okay, and that data can be deleted with the help of some kind of SQL query, and you can update the data also. So for that purpose, the kind of application you have written where separately you have to open the PostgreSQL and you have to create the database, then you have to create table, and after that with the help of some kind of object which is available in the language like PHP, with the help of that object and some kind of built-in method, you can work with the database. You can establish connection first of all, then with the help of executing the SQL query, you will be able to fetch the data from the database, or you can insert data into the database. So there are so many methods, are built-in methods are available, and these methods are, you can say, object oriented. Okay, so this kind of things you have done, but here we are going to do some different kind of thing with the help of MongoDB. So now you can divide the databases in two category. One is relational and another is NoSQL, or you can say SQL and NoSQL. So relational means SQL, where we are going to use many SQL languages, but there is one more kind of thing which is NoSQL. So MongoDB is one of the most popular NoSQL database. So let us discuss a little bit about NoSQL. So web development usually required to use a relational database to store persistent data. So as we know that in case of relational database like PostgreSQL or MySQL, that kind of things is required to store the data. But what happened if the size is large? So in that case, the scaling problem comes. So just we are discussing about the problem with SQL. Okay, problem with SQL database is if the application size, if the web application size is increases, so in that case there is a problems with scaling. Scaling means if you want to increase the columns, suppose you are using SQL database, and if you want to add one more column, or suppose you want to add one more table, suppose it requires by some kind of application that you need to create another table. For example, suppose you have developed one application, but after some time, suppose you want to increase one more table. Okay, so in that case, the whole structure you have to change. If you are just adding one more table into the SQL database, so in that case, what happens? There are relationship between tables. So in that case, if you add one table, since that table is related with another table, so you have to add columns to another table. So automatically the number of columns will be increases. So it affects one or two, three tables. So whole structure will be changed, and if whole structure will be changed, accordingly you have to change the user interface also. Okay, because suppose you want to add one more column, so in that case one more field will be increases in your user interface. So this kind of problem is coming. Okay, so that is called a scaling problem. So what is the solution? So to solve this problem, there are some technologies are used, and mostly we use key value storage solution. Okay, key value pair we use instead of dividing the database into rows and columns. We use key value storage solution. There are three things that is designed for better availability. Okay, so if you are using key value pairs, so your data availability will be increased. Okay, because directly with the help of key you can approach to the that particular data. But in case of SQL, availability is not very much good, because one if you are accessing one table, so the connection of that table there is another table, so from another table you can access the data. Okay, you might remember the nested select query. Okay, so with the help of nested to nested select query, you can access the single data from a particular table. So availability is not better in case of SQL, but in case of NoSQL or in case of key value storage solution, the availability will be better. Then simple querying. Okay, so query, there is a nested select query, you might remember, which is very difficult. Another is joining the table, left join or outer join, inner join. So that kind of problem comes. There are accessing the data is very much difficult. So most of the case query is not simple. Query is very much difficult. But if you are using key value pair, key value storage solution, so in that case, your query will also be very simple. Since there is no relationship between one or two table, so obviously the query will be simple. Then next is horizontal scaling. So here scaling is not vertical, scaling is horizontal. So just you have to add documents. Okay, no need to add the columns or no need to establish the relationship like primary key relationship, foreign key. So this kind of relationship is not there. Okay, but instead of that, just you divide the your database into the different documents. So the scaling will be horizontal. So if you want to add one more, that is one more category of data, okay, or you can say one more set of data. So just you have to add one more document. So your document will be increased. Okay, number of documents will be increased if you want to increase the data or if you have to increase the field. So that is called as horizontal scaling. Okay, so scaling is horizontal. So just you have to add document by document if you want to scale your database. Now there are different kind of categories you can divide to the NoSQL database during the evaluation. So these are the different design pattern. Okay, like key value storage. So as we have discussed key value storage, there are many benefits of the key value storage. Then we have column storage. Okay, column storage is also one of the kind of storage where we divide the database into the different columns. Then object storage, so it is object oriented. So first we need to create an object, then with the help of object you can access the data, you can fetch the data. So that is called as object storage. And document storage. So these are the different storage design pattern. This storage design pattern belongs to NoSQL database. Now let us discuss a few more things as compared to relational database. So in relational database, data is stored in different tables. So as you know, but in document oriented database. So here out of these four design pattern, we'll discuss document oriented database. Okay, because MongoDB is based on document oriented database. So here we'll discuss document oriented databases. So in document oriented database, instead of using tables, store hierarchical document in standard formats such as JSON and XML. So here we just follow a format in a document. So just we create document hierarchically, so that this kind of database is called as document oriented database. So while developing your application, you often encounter another problem like model changes. So just as we discussed that if you suppose the model is changed, that is suppose you want to shift from one model to another model. Suppose you want to switch your application from one model to another model. So in that case, it is very difficult to manage the things in case of SQL, but it will be not very much difficult in case of NoSQL. So however, document-based database are often schema-less. Okay, so here the schema is there, but schema is very less in case of document-oriented database, which means you can store different object in a single collection of objects without changing anything in your database. Here you can assume that we are just storing objects. Okay, so in a single object there are multiple objects are stored. So this kind of things are there. And in that case we don't change the database, just we have to manage the that is document. NoSQL represents any data store that does not use SQL. Okay, so as we have discussed that NoSQL, in NoSQL we are not using SQL. SQL is not there. That means SQL query, whatever we have learned, that is insert, update, select, delete. So this kind of query we are not going to execute. This is not SQL, but this is NoSQL. So here there are document store, object store, key value stores. These are the things already we have discussed. Now examples. MongoDB is one of the NoSQL database. Apart from MongoDB, we have Redis, then Memcached, Cassandra. Okay, so these are the some NoSQL database, but MongoDB is most popular database. Now, if you compare NoSQL with relation, so which one will be faster? NoSQL will be faster because they don't typically follow a predefined schema. So in NoSQL, we don't have predefined schema, or we don't enforce data consistency as strictly as there in relation database. So in relation database, there is a data consistency. Okay, so if suppose one place you are changing the data, so it should be reflected in another table. Okay, in suppose in one table you updated some data, so if suppose there is relationship between two tables, so in another table also the same reflection should be there, otherwise there may be consistency problem. So this kind of problem comes in case of relation database, because in relation database the tables are related with each other, but in NoSQL this is not the case. So here there is no any strict type of things are there in NoSQL database, and here you don't, there is no predefined kind of data schema is there. Schema is there but not predefined schema. So what happens? NoSQL databases are very faster. This means that NoSQL data stores are usually suited to prototyping and social media application, okay, that don't require the data to be perfectly consistent at all times. So here you can consider Facebook as an example. So NoSQL is perfect for Facebook because what happens in Facebook, most of the users wants to store their data, but different users store data differently. Suppose one student stores three types of data, another student stores six kinds of data. So it depends. So depending on the user, there are different types of data can be stored. So how you can manage it? Because suppose if you follow SQL, so in that case you have to create columns. So suppose you create 20 columns to store the 20 types of data. So in that case, what happens? Most of the columns are empty. Okay. So if you suppose you are establishing a relationship between this table to another table, so in that case, managing the whole thing will be very much difficult. Since we are using social media kind of application, so this will be more difficult because the category of data is flexible. That is, category of data is varying depending on the users. So it is more difficult. But suppose the types of data, or you can say category of data is fixed. You can consider the example of a bank database. Okay, bank. So in bank application. So in some bank application, if suppose a user want to enter some information, some data, so the category of data is fixed. Okay, because something is compulsorily user have to enter, like account number, then amount to be withdrawn or whatever type of account. So this is fixed. So type of data is fixed. What kind of data you the user want to store in a bank database, which is fixed. So in that case, you can prefer SQL. So it will be more manageable. But if suppose the type of data or category of data is not fixed, as we have discussed in case of Facebook, so in that case, the managing data is difficult if you are using SQL. So in that case, we will use NoSQL. Okay. So now this slide is just for brief history of MongoDB. So development of MongoDB began in 2007 at a company named Tengen. So previously the company name was Tengen, and after that the company name changed. Previous they started MongoDB, developing MongoDB in 2007, and in 2009 MongoDB was open sourced. So in 2009 MongoDB was open sourced. Now after that Mongo became so successful that Tengen changed its name to MongoDB Inc., used at many high profile companies. So these are the companies, you can say the list of companies who use MongoDB. Okay. Then Mongo stores data in binary JSON. So JSON is there, but this is not the completely JSON, but here we are using binary JSON. So this is the just formatting, document formatting is binary JSON. Then Mongo's native use of JSON provide a simple and convenient interface for JavaScript application. So since we follow JSON kind of formatting, so in that case it will be more convenient in JavaScript application. Okay, because JSON is terms we use in JavaScript. So in that case, it will be more convenient. MongoDB is more convenient is JavaScript application. So since we are using JavaScript in everywhere, so in that case, MongoDB is most preferable.